Let's start talking about radical expression, how to deal with them on the SAT, all the types of radical that we can run into the SAT, and let's talk about complex number. Let me share the screen. Now, when we talk about radical expression, we are talking about root, square root, and specific is we always call it square root in specific because we assume that the n is equal to index is equal to 2, but there can be even a cubic root, like in this case, a root out of 4 and so on. The radicand will be the number that will be reduced, and basically that intended you'll divide by itself. So if we have 20 by not by itself, by the factor. So for example, if we have square root of 25, we know that the result of this one will be just equal to 5. Now, what's important for us is to understand how to deal with that on the SAT. And we need to remember a couple of definition or also way to write squares, roots, or roots in general, and a couple of properties. The first thing that we need to remember is that whenever we see a fraction, whenever we see an exponent out of a fraction, like in this case, these are just expressing roots. So a to the power of 1 over 2 is expressing just square root. A to the power of 1 over 3 is expressing a cubic root. So if I find something like 2 to the power of 3 over 2, this is just a square root of 2 to the power of 3. Very important. Another couple of important information that we need to remember are the property. There are property for radicals. One is the property or multiplication of values inside the square root or the root, which, for example, in this case, square root of a multiplied by b can be written as square root of a and square root of b. And this is valid also for fraction, which we can rewrite as square root of a over square root of b. The same can be applied for any type of roots. This is very advantageous for some specific exercise. For example, before we wrote 2 to the power of 3 over 2, which we can rewrite as square root of 2 to the power of 3, which also can be rewritten as square root of 2, then multiply square root of 2, let's multiply square root of 2. Or better say, let me do a step before, a step earlier. This one can be rewritten as square root of 2, then multiply 2, then multiply 2. Since this is a series of multiplication, we can write it as a square root of 2, then multiply square root of 2, then multiply square root of 2. And whenever you have a multiplication of 2 square root that are the same, that can be just written as 2. So these will end up to be just 2 square root of 2. Parentheses. We could have already seen this one by just applying some low exponents, but that's a little bit too complicated. Let's keep it like that. Now, what we can find on the SAT that is important to do and to know. How can we, for example, solve or simplify this square root of 32x to the power of 2? That's an interesting one. So the first thing I can do is split the numbers with the exponent. So I can write that one as square root of 32, then multiply square root of x to the power 2. So by doing that, these will just become x, because remember here there is just a 2 on that square root, so that will become x. Now 32 can be always prime factorized. So if we prime factorize 32, this one would be 32 divided by 2 is 16, divided by 2 is 8, divided by 2 is 4, divided by 2 is 2, and 2 divided by 2. So 32 can be rewritten as a series of multiplication of 2 by 2 by 2 by 2 by 2. 5, 2 to the power of 3 or 5, sorry, 2 to the power of 5. At the same time, these would be 4. These would be 4, and this would be 2. So I could rewrite these as square root of 4, then multiply square root of 4, then multiply square root of 2. Square root of 4 and square root of 4 are 2 and 2. So what I have left is 2 by 2 by square root of 2, which is 4 square root of 2 plus the x that was here, and my final result will be 4x square root of 2. So let's review it again. To help myself to simplify a square root like this, I compose whatever is inside square root. This one, since it was already to the power of 2 and a square root, this one will become x. This number I could prime factorize to find all the possible number that multiply can give me this one. I know that the couple can go inside the square root and it will become just one of those. And I end up with this 4x square root of 2. Let's see now a case like this one. If a to the power of 2 over 3 is equal to 6, then a to the power of 4 over 3 is, in this case, the first thing we need to do is find the value of a. So first of all, a of 2 to the power of a to the power of 2 over 3 can be written as cubic root of a to the power of 2. And all these is equal to 6. Whenever we deal with square root, cubic root, what we do to eliminate is exponent. The opposite of a root is an exponent. So in this case, since my root is on 3, I gotta restart. Okay. 1 second. And we'll restart. So we were saying, let me share again the screen. In this case, a to the power of 2 over 3 equal to 6 can be written, a can be written as a cubic root of a to the power of 2. And all this is just equal to 6. Our goal is to find a to the power of 4 over 3. To find out what's this value, we need to find the value of a. So we need to start working on this equation. So since the equation is like that, my first goal is to simplify it. Since I want to find a, I need to eliminate, first thing, my radical. How can I eliminate my radical? By using exponents, exponentials. Since exponential are basically the opposite of the square root. So since here the root is to the cubic, here I'm gonna do to the power of 3, but since it's an equation, whatever I do on my left, I need to do to my right. So I'll do the same here. What's gonna happen is that the left, I will have left a to the power of 2 equal 6 to the power of 3 in the other side, which is equal to 216. Now, though, I need to find a. Since a is to the power of 2, I have to do square root of 2 in both sides. And that's what we're gonna do. Once you do the square root, you will get that this one will go away. 216, remember, is just, let me rewrite it in yellow, 6 by 6 by 6. Since it's in the power of 2, we can rewrite this one as 36 by 6. Putting them to the power of 2 both, this one will become 6, and this is still the same. So my final result is that a is equal to 6 square root of 6. Again, before we had 6 to the power of 3. Since now we are writing square root, this 6 to the power of 3 can be written as 6 by 6 by 6. We take in consideration just these two 6, and they're gonna be out of the square root because their sum is 36. I'm sorry, the multiplication is 36. 36 to the square root is gonna be just 6, and this one stay there. So I found my value of a. Now I need to find my value of a to the power of 4 over 3. What does it mean a to the power of 4 over 3? It means cubic root of a to the power of 4. My a is 6 to the power of 6, right? To the cubic root, sorry. So cubic root of 6 to the power of 6 to the power of 4. This one can be converted as 6 square root of 6. This is cubic root. 6 square root of 6 and multiply 6 square root of 6. Then multiply 6 square root of 6. Then multiply 6 square root of 6. If you see, here we have square root of 6, then multiply square root of 6, and square root of 6, and multiply square root of 6. So what we have is actually square root over the multiply square root cancel out. So we have 1, 2, 3, and 4, 6 already. 6 by 6 by 6 by 6 plus d6 by the multiplication of the two square root and this multiplication of square root. So what we are left is 6 by 6 by 6 by 6 by 6, which is just cubic root of 6 to the power of 6, which cut this one out and give me left the 6 left with power of 2. So my final answer for a to the power of 4 over 3 will be 6 to the power of 2, which is equal to 36. And that's how you solve it. I know it seems long, it actually is. I don't think you're gonna find something like this on the exam itself, but it's a it's a good way of training. So do them. I prepare some of these kind of problems for the homework, so get ready to do it. right before, I kind of show you how to solve any radical equation. And here we have the example, another example where we need to solve to find x. Before, we use the method for solving an equation to find a in this one. Here we want to find x. So how do we solve an equation when there is a radical? As I showed you before, we eliminated the radical. We isolate it and we eliminate. How we eliminate it? By using the exponential by using exponentials. Okay. So for example, in this case, here we need to find the value for x. What do we do? The first thing we're gonna do is move the integers that is on the left, which is 4. So I'm gonna move it. I'm gonna have left 1/2x here equals 7 minus 4, because what I do is subtracting 4 on both sides. So what I have left here is gonna be 3. So here I'm gonna have square root 1/2x equal 3. To get rid of the square root, I'll power up both sides by 2. And so this one will go away. But on my right side, I will have 9. So now I have 1/2x equal 9. That means that to isolate my x now, I need to multiply by 2 both sides. And I will get that x is equal 18. That's all. The process is simple. You need to power up for whatever is the exponent. In this case, we want to find the solution of these other equation. It's the same equation, but right now we have square root on the left, square root on the right. Even better, you don't do anything. You just go and power up everything. So 5x minus 12 equal 3 root of 2. Since you have square root on the left, square root on the right, everything is together. Basically, you do powered up both sides. Doing that, you eliminate it. It's gonna be to the power of 2. So what you get is 5x minus 12 equal 9 multiply 2. 5x equal 9 by 2 is 18. The 12, negative 12 moved in there, say is positive 12. 18 plus 12 is 30. X will be 30 divided by 5, which is 6. That's our answer, 6. And that's it about radicals. I think I showed you everything about it. Now, what I want to talk about is complex number. What are complex number? Complex number is a method to keep solving any type of equation or algebraic expression when you run into this situation, square root of a negative number. When you have square root of a negative number, you have no solution. So to get rid of this problematic, you will substitute square root of -1 with I, and you carry on your operation. Now you will treat I as a sort of a variable until you get to I to the power of 2. Only in that case, you will switch to -1. So I is a particular case that represent, when you see I, it represents square root of -1. And you will treat it as a variable until I becomes to the power of 2. In that case, you just substitute as -1. Let's see what I'm talking about. And I want to show you all the possible cases you run into. For example, what if the SAT asks you to simplify I to the power of 35. What do you do? Well, in this case, what you will do is taking all in consideration of all the exponential rules, power rules that we've studied so far. So, first of all, you know that I is to the power of I is equal to the square root of -1. But at the same time, you know that I to the power of 2 is -1. And that's what you want to work on. So first thing that you want to notice is that the exponent is negative, is an odd one. So the first thing we will do is rewrite this one as I, then multiply I to the power of 34. This is still I to the power of 35, but now you have an even power in one side. And why you did that? Because now you can rewrite this as I still, then multiply I to the power of 2 then multiply power of 17. This is power of a power, and that represents 34. Okay. Now, why do you think I did that? Because I know since here we started with an odd power, that something is going on there, and it's gonna be even it's gonna be either the result of I or negative I. In this case, I already know it's gonna be negative I. Why? Because here I stay the same. As I say, whenever we have I to the power of 2, it becomes -1. And now -1 to an odd power will stay negative. So it's going to be I then multiply -1. So your final answer is negative I. Try those type of exercises. There are some examples on the PDF I provide to you, plus many homeworks about it. So you can have fun, hopefully. Let's see that you have a case of multiplication of square roots with negative number inside. What do you do? Well, first of all, we know there is no real solution for this specific case, but we can rewrite those two square roots because -5 is the result of multiplication on the square root of -1 that multiplies square root of 5. And -10 the same, is the result of the multiplication of square root of 1 that multiplies square root of 10. Square root of 1, we know, can be substituted with I. So now what we have is I square root of 5, then multiply I square root of 10. I then multiply I is equal to I to the power of 2. And square root of 5 then multiply square root of 10 is equal to square root of 50. Everything that is inside a square root can be multiplied to each other. Remember, that goes to the first rules we were studying before. Now, I to the power of 2, as we know, can be changed as -1. Then multiply square root of 25 by square root of 2. Why I did that? 50 is a number that can be, if we do factorization, is the result of 5 by 2. I'm sorry, no. Yeah, 5 by 2 by 2 by 2, something like that. Since I know that 5 by 5 is going to be 25, square root of 25 is just 5, I simplify by this sort of multiplication, and I know that my final result will be -1, then multiply 5, then multiply square root of 2, which is -5 square root of 2. That's my final answer. I hope it's clear. This one is not clear to you. Review prime factorization, okay? This one comes from prime factorization. What if we run into something like this? What's this? This is just the sum of two binomials. And that's how we're going to treat it. We're going to treat it as two binomials because although there is I, we know that in this case, we treat I as a variable. Since the sum is the sum between binomial, you know that this one will be sum with this one and nothing else. And this one will be sum with this one and nothing else. So my result will be 4 by 5. 4 plus 5 equal 9. Negative 3i plus 4i equal I. That's it. It's that simple. Okay. What if, and this is one to last, what if we run into something like this? We need to solve this equation. We go and solve this equation, so we isolate the x, so we'll have x to the power of 2 equal 75 when it's moving the other side is negative 75 over 3. 75 divided by 3 is 25, so we have x to the power of 2 equal negative 25. Now, since I'm looking just for x, what I will do is a square root and square root here. That will cut this exponent away. And now I have that x is equal square root of negative 25. But 25, negative 20, square root of negative 25 gives me no real solution. But I can rewrite this as square root of negative 1, then multiply square root of 25. This one will become just I. So what my final result could be x equal square root of 25 is 5. So x is equal 5i. So watch out for this case. Most of these cases are going to be multiple choice answers, so you could see if there is an imaginary number involved. Last one for today. Which of the following is equal to the square root of negative 1 minus square root of negative 4 plus square root of negative 9? Well, that's easy. We know that this one, the very first one that we see here, is equal to I. I'm going to write it. So again, we clearly see that there is a bunch of negative square root to a negative number, which we can solve just with a complex number. So square root of negative 1 is equal to I. Square root of negative 4 is I square root of negative 2 and square root of 4. And the square root of negative 9 is just I square root of 9. This will become I minus 2I plus 3I. I plus 3I is 4I minus 2I is equal to 2I. 2I is my answer. If you have any question regarding this type of exercise, let me know next class. This is a very important one, so study. I'll be here for you. I'll meet you at the end of this week. Good luck and send me your homework. I'm waiting on your homework, guys. Good luck. Ciao.